General Motors, the biggest automaker in the US, is diving headfirst into the electric vehicle game. They're not just talking about it, they're betting their future on it. GM CEO Mary Barra has a bold vision for an all-electric future where cars contribute to zero crashes, zero emissions, and zero congestion. She's confident that GM will dominate the US EV market by the middle of the decade, claiming they'll take the #1 spot. The lithium battery. The star of their EV push is the lithium battery. This isn't just any battery. It's a game plan wrapped in cutting-edge tech. The lithium battery starts with a single cell, a building block if you will, that could be adapted to fit into all sorts of vehicles. Imagine a system so versatile it can power a massive Hummer, a sleek Cadillac L, or pretty much anything else GM dreams up. And they can do it quickly. GM is putting its money where its mouth is and is planning to pour $35 billion into electric and autonomous vehicles by 2025. They're aiming for the capacity to crank out 1 million EVs annually and want to have over 30 electric models hitting the market globally during that time. Most of these will run on the new lithium platform. By 2035, GM plans to make all its light-duty vehicles electric, but they're not stopping at personal cars. GM is also expanding into the commercial EV sector with its BrightDrop brand. They've already started delivering BrightDrop vehicles to FedEx and have secured a contract with Walmart. It's clear they're serious about carving out a big slice of the EV market pie. So, what makes GM's lithium platform stand out? They believe they've nailed it by partnering with LG Energy Solutions, a battery cell manufacturing powerhouse, and building 3 massive battery factories in the US, in Ohio, Tennessee, and Michigan. GM is confident that this collaboration and their innovative battery tech will make their vehicles some of the best on the market. The lithium platform isn't just about better batteries. It's a complete overhaul of how EVs are built. From the motors to the software, the lithium battery itself is a large-format lithium-ion design, the heart of GM's EV strategy. Tim Grew, GM's electrification guru, explains that it's all about combining cutting-edge components into a system that works together flawlessly. The battery's modular design means it can be scaled up or down to fit everything from heavy-duty trucks to sleek sedans. The way a battery works might sound like science class, but it's fascinating when you break it down. GM's engineers describe it in relatable terms, comparing the anode and cathode to parking garages where lithium ions park depending on whether the battery is charging or discharging. What makes the lithium platform particularly innovative is its battery chemistry. Traditional EV batteries often rely on cobalt, which is pricey and not easy to source. Tesla, for instance, has been using a mix of nickel, cobalt, and aluminum in many of its vehicles. But GM's lithium platform is breaking new ground with a chemistry that uses less cobalt and incorporates other elements to reduce costs and reliance on hard-to-get materials. They're even working toward cobalt-free designs, which could be a game changer for the industry. This isn't just about making batteries cheaper. It's about making them better for the environment, too. Mining cobalt and other rare materials can be harmful and politically tricky. By reducing reliance on these resources, GM's lithium batteries could help make EVs more sustainable while also lowering costs for consumers. The new ecosystem. Beyond the tech, GM's vision is about building an entire ecosystem around EVs. Their 3 new battery factories are just the beginning. They're also investing heavily in research and development partnerships and new manufacturing techniques to ensure they can scale up production quickly and efficiently. They're not just trying to catch up to companies like Tesla. They want to leapfrog them. GM's commitment to innovation is evident in their battery lab where scientists and engineers are constantly experimenting with new materials and designs. They're not just testing for performance. They're thinking about how these batteries will hold up over time, how they'll perform in extreme conditions, and even how they can be recycled at the end of their life. The modular design of the lithium battery is a big selling point. Instead of designing different batteries for different vehicles, GM can use the same basic cell across its entire lineup. This makes production simpler and cheaper while also giving engineers more flexibility in designing vehicles. It's like having a set of Lego bricks that could be rearranged to build anything from a sports car to a scimitar. And then there's the software. Modern EVs are as much about code as they are about hardware. And GM is investing heavily in the digital side of things. The Lithium platform includes new software designed to optimize battery performance, improve charging times, and even update the vehicle remotely. This kind of over-the-air update capability is something Tesla has been doing for years, but GM is catching up fast. GM is teaming up with LG Energy Solutions to create a battery chemistry that shakes up the game. Their new design cuts the cobalt content by a massive 70%. Why is this a big deal? Because cobalt is one of the most expensive parts of a battery. By reducing its use and adding elements like nickel, manganese, and aluminum, GM is on track to bring down the cost of its lithium battery packs to under $100 per kilowatt-hour. That number is like the holy grail for EV makers because it's the tipping point where EVs become just as affordable as gas-powered cars' battery management system. But GM isn't stopping there. GM is taking a unique approach to battery technology with its lithium platform, setting itself apart from competitors, including Tesla, in a number of important ways. One of the standout features is GM's advanced battery management system. While many companies monitor the battery as a whole pack, GM goes a step further by monitoring individual modules within the battery. This means that if a particular module needs replacing, GM can swap out just that part instead of replacing the entire battery pack. This approach is not only smarter but also more cost-effective. Additionally, it allows for mixing and matching newer technologies with older packs, ensuring that upgrades can be made without disruption. To put this into perspective, think of the battery in your phone or tablet. Most of these devices use pouch batteries, but these aren't built to handle the tough demands of an electric vehicle. GM has taken the basic idea of pouch batteries and made them more durable and suitable for the automotive world. They've reinforced the design with added insulation, ensuring the batteries can endure the lifespan of a vehicle while maintaining efficiency. One of GM's key innovations is how they pack the cells. Rather than leaving gaps between them, GM arranges the cells tightly side by side, reducing wasted space and maximizing energy capacity. This design is incredibly flexible, allowing GM to adjust the shape and configuration of the cells depending on the vehicle's needs. For example, their cars in China use a prismatic in design, which is shorter and wider compared to the longer cells typically used in the US. This ability to adapt to different market demands gives GM a significant edge in producing vehicles tailored to regional preferences.